Hi all, I am K. Surya, working as assistant professor in the Department of ECE at SNS College of Technology. In this video, let us see about parallel in, parallel out shift register. Digital circuits are important for processing and manipulating data efficiently. The shift register is an important part of these circuits, which enable sequential data shifting in and out. Among the various types of shift register, parallel in parallel out shift register stands out for its ability to handle data in parallel, offering significant advantages in certain applications. A parallel in parallel out shift register is a collection of flip-flops arranged in a series with each flip-flop capable of storing one bit of data. The primary characteristics that distinguishes PIPO shift register is its ability to load data and output in parallel manner. Unlike other shift registers that deal with serial input and output, the parallel loading and output capabilities of a parallel in parallel out shift register makes it a powerful tool in many digital systems. We'll see few key terminologies related to parallel in parallel out shift register. So you know that a shift register is a digital circuit consisting of flip-flops used to sequentially store and shift the data. Flip-flop is a simple building block of variable name that can store some data. It can be operating in 0 or 1 state. Input to the PIPO register from the data simultaneously uploaded to the flip-flops allows multiple files to be entered simultaneously. Output of the parallel in parallel out shift register, which can access data stored in the flip-flops. It allows viewing multiple files at the same time. Clock signal, it's a timing signal used to synchronize the renaming job. It determines the amount of data that has been changed or replaced in the bit. Serial input, another input method of converting the data to serial input, where data is entered bit by bit sequentially. Another output method for extracting data from a switch, where the data is output bit by bit sequentially. You know what is shift left and what is shift right. Shift left is the function which shifts the data to the left, and the shift right is the function which shifts the data to the right. So this is the block diagram of a parallel in parallel out shift register. We'll see how it works. Um, so in a 4-bit parallel in parallel out shift register consists of 4 flip-flops. It is labeled as D0, D1, D2 and D3. So each flip-flop can store 1 bit of data. The data can be loaded into the flip-flop simultaneously through the parallel input known as the data input. Once the data is loaded, it can be read out simultaneously from each flip-flop to the parallel outputs. Each flip-flop contains a pass sequentially to the following flip-flop to shift the data out. This can be accomplished by providing a clock signal that triggers the shifting operation. When the clock signal is activated, the data in each flip-flop is transferred to the adjacent flip-flop, allowing new data to be loaded into the first flip-flop. So these are the few advantages of parallel in parallel out shift register. Uh, so it's used in business concerns itself with its core competencies, while the specialized tasks are hived off to suppliers. So it's used in specializations. It has a good flexibility. It has a facility for scalable production without heavy investments in resources, and it has a reduced capital investment. So there's a less need to invest in the equipment, tooling, and inventory. Next one is risk management, where diversifies supply chain as a way of mitigating risk of internal failures, and it leverages supplier expertise. Here, the components can be of higher quality coming from specialized suppliers. Next one is shorter lead times and high speed data transfer. Some of the disadvantages of PIPO shift registers are it has higher pin count and its potential for signal skew is high, and increased complexity for large scale design and limited flexibility. Some of the applications of parallel and parallel shift register are it's used for storing data, and it's also used for transferring the data and in data manipulation. It's also used in serial to parallel conversion. Hope you understood how a parallel and parallel shift register works. Let us take up some assessment questions. In a parallel in parallel out shift register, D0 is equal to 1, D1 is equal to 1, D2 is equal to 1, and D3 is equal to 0. After 3 clock pulses, the data outputs are 0, 0, 0, 1. How much storage capacity does each stage in a shift register represent? So as you know, each flip-flop has only 1 bit memory storage. Here the answer is 1 bit. Thank you everyone for watching this video.